Number 1, which number does not represent a whole number? 8 is a whole number. 12 is a whole number. Number 10 is an integer. And 15 over 3 would be 15 divided by 3, which is 5, which is a whole number. So the one that is not a whole number is C. Number 2, which describes a rational number. Any number found on a number line. Well, yes, but that's not a complete definition. All numbers greater than 0. It could be a number less than 0, like -5. That would be irrational. Any number that can be expressed as the ratio of two integers where the denominator is not 0. J says any decimal number. Well, yes, it is a decimal number, but it could also be a whole number. That's also irrational. Or it could be a negative whole number, which is also irrational. Number 3, Marion was asked to create a set of numbers so that 2 were integers that were not whole numbers, 2 were rational numbers that were not integers, and 2 were whole numbers. Which of the following sets would satisfy the criteria for Marion's set? Well, 11 is a whole number, 6 is a whole number, -3 is an integer, -4 is an integer, 1.5 is rational, and 5/12 is rational. Looks like it would be that answer choice, but I'm going to check some of the others. 9 is a whole number, 100 is a whole number, 1.11 is rational, 12 is whole, -6 is an integer, and 20 divided by 3 wouldn't come out even, so that means it's rational also. 5 is a whole, 3 is a whole, -8 is an integer, -14 is an integer, 3.5 is a rational, 24 divided by 12 would be 2, which is a whole number. 20 is a whole number, 12.5 is rational, 9 is whole, -14 is an integer, 28 is a whole, and 4.5 is a rational. So A was the correct answer. Number 4, which statement is not true about integers? All integers are rationals. Yes, because the integer circle is inside the rational, so yes, that's true. If 2 integers are added, the sum is always an integer. True. If 2 integers are subtracted, the difference is always an integer. True. And if 2 integers are divided, the quotient, that would be the answer, is always an integer. Well, if you divide, you could get a decimal, so that one would be not true. Number 5, which statement is not true? -13 is a whole number and an integer. Well, -13 is not a whole number. -13 is an integer and a rational. -13 is a rational number, but not a whole. -13 is not a whole number. So that makes it answer A. Number 6, this Venn diagram shows the relationship of the rational numbers. Which of the following is a rational number but not an integer? So we're going to put these numbers into our Venn diagram. 6 is a whole number. -3 is an integer. 14 divided by 2 is 7, so 7 would be a whole number. That's a whole number. And 32.5, any decimal or fraction goes on the outside. So which one is not an integer? The only one outside of integers is 32.5. Number 7, which number does not represent an integer? Well, -13 is an integer. 8 is a whole number, but if it's a whole number, it's also an integer. Negative 13.5 is rational. And 10 is also a whole number. And if it's a whole number, it's also an integer. So that means our answer is C. Number 8, to which set or sets of numbers does the number negative 5 belong? Well, negative 5 would go in the integers. And if it's an integer, then it's also a rational, which is letter H. Number 9, which of the following represents a rational number that is not an integer? Well, negative 10 divided by 2. 10 divided by 2 is 5. And it would be a negative, so that makes it an integer. 6 is a whole number. 16 divided by 3 would not come out even, so that makes it a decimal. And any decimal is a rational. And 10 is a whole number. And if it's a whole, it's also an integer. So the one that was not an integer is C. Number 10, which statement is true about rational numbers? All rationals are integers. If you remember the circle, rational includes integers and whole numbers, but not all rationals are integers, like negative 5.6. That would be rational, but not an integer. 0 is not a rational. Well, 0 would go here, and that's inside rational. All rational numbers are whole numbers. No, they can sometimes be fractions. The opposite of a rational, like negative 5.6 and 5.6, those are opposites, and they are both rational. The next section starts talking about converting between decimals and fractions to decimals. So number 1 says, how is 1 2/5 expressed as a percent? Well, remember, we need to change 2/5 to a decimal. So 2 goes in the house, 5 goes outside, 5 goes into 20 4 times. So the decimal part is 0.4. And I need to put my whole number with it, so it's 1.4. What's 1.4 as a percent? Remember, we move the decimal over 2 spaces and put in a 0. That makes it 140%. So was it 1.4%? Was it 140%? Was it 0.4%? And it certainly wasn't 100 2/5. So the correct answer is B. Number 2, Joel bought a new baseball glove for $24. He received a discount of 20% off the original price, which fraction or decimal is equivalent to 20%. Well, percent means over 100. So it would be 20 over 100. And remember, Miss Garrett said if they end in zeros, you can just mark those off. So that leaves 2 over 10. And remember how she showed us to write the factors for each number and look for what they have in common. So they both have a 2. Box it and mark it out, and that leaves the 1 and the 5. So 1/5. Well, it says 2/5 on the answer choice, so I know that can't be right. What would 20% be as a decimal? If you move it over 2 spaces, that would be decimal 20. Is decimal 2 the same as decimal 20? It is, because that's just a placeholder. So H is correct. Number 3, which pair of numbers are equivalent? So the first one says 0.75. Remember 1, 2, 3? There's only 2 numbers, so that means we only get 2 zeros. So it should be 75 over 100, not 75 over 10. The next one says 0.8. And if I want to change 0.8 to a decimal, how many times do I move the decimal? 2 spaces. So that would be 80%. 80%. So that one's wrong. If we want to make 0.4 into a fraction, it would be 4 over only 1 0, 4/10. And if I simplify it, that would become 2/5, not 1/4. D says 0.03. Remember, we moved the decimal 2 spaces to change it to a percent, so that would be 3%, which is what they wrote. So the answer is D. Number 4, 3 students wrote a relationship between a decimal fraction or percent. Which student wrote a correct equation? Well, Maxie wrote 75% is 3/5. And that's one of those benchmark fractions she talked about. 75% would be 75 over 100. What is 75 out of 100? Isn't 75 3/4? How do we write 3/4 as a fraction? 3 out of 4, which is not what Maxie wrote. So Maxie wrong. Bernice wrote 5.05 is 50%. If we move the decimal 2 spaces, that's going to be just 5%. So is that right? Nope, Bernice is not right either. Leanne wrote 3/8 is 0.375. Well, I'm going to have to divide that out. 3 goes in the house, 8 goes outside the house. And then 8 doesn't go into 3, so we put a decimal so we can put some more zeros. How many times does 8 go into 30? Three times? Because 3 times 8 is 24. 30 minus 24 leaves 6. Put down another 0. How many times does 8 go into 60? 7 times. Because 7 times 8 is 56. 60 minus 56 leaves 4. Put another 0, bring it down. How many times does 8 go into 40? 5 times with nothing left over. So this one, Leanne is right. Only Leanne is right. Number 5 says, which of the following is not equivalent to 0.45? Remember 1, 2, there's 2 spaces, so I get to put it over 100. So 45 over 100. That means A is right. How would that be written as a percent? Remember, you just move the decimal 2 spaces, so that would be 45%. That means B is right. So C and D must be the simplified fraction. So I'm going to make my T-chart so I can simplify the fraction. 1 times 45, 3 times 15, and 5 times 9. And then the factors for 100. 1 times 100. 2 times 50. 4 times 25. We've written this one a bunch. Probably going to need to memorize these. And which one do they have the same? 5. So box it, mark it off, and that leaves 9 over 20. Well, neither one of those fractions is 9 over 20. Could I multiply 9 times something and maybe get 11? 9 times what makes 11? No, nothing. Could I multiply 9 times something and get 18? Yes. And I'd multiply it times 2, and that would be 18 over 40. So the one that's not true is C. 6. Which pair of numbers is equivalent? Well, the first one is 0.16. 1 6. So if I try to divide that, put 1 in the house and 6 outside the house. And if I divide that, I kind of get 0.16, but then it keeps going. So the 6 keeps going. That means that this should have had a hat on top of it. And 6 does not have a hat on F, so he's wrong. For G, it says 0.07. If I move the decimal 2 spaces over, that would be just 7%. That one looks right. H says 4/10. Well, 0.04 means it should be 4 over 100, which is not a 10. Missing a 0. And the last one, percent means over 100, so that should be 9 over 100. So the correct answer is G. Number 7. Mel asked 50 students in her school which fruit they preferred. The table below shows the results of her survey. What decimal represents the fraction of students who prefer oranges? How many liked oranges? 12. Out of what was the total? It says 50. So to change a fraction to a decimal, we do top in, bottom out. So this is going to be a little bit of dividing. 50 doesn't go into 12. How many times will 50 go into 120? How many 50s does it take to make 100? 2. Then we'd have 20 left over. Put another 0, keep going. How many times will 50 go into 200? 4 times. Because 4 50s make 200. So our decimal is 0.24. 0.24. Number 8, which of the following statements is not true? A dime is 10% of a dollar. Is a dime 10%? Yeah, it's 10 cents. Is a dime 2%? No, it's 10. A penny is 1%. A penny is 1. A nickel is 5%. How much is a nickel worth? 5 cents. So G is the not. G is the not.
So G's right.
That's correct. Benjamin has 3 dimes and 4 nickels. What percent of a dollar does he have? How much is 3 dimes? 30 cents.
30 cents.
And nickels are 5 cents each. So if I had 4 of them, that would be 20 cents. So what's 30 cents plus 20 cents? 50 cents. 50 cents would be how much as a percent? 50%. 50 cents is 50%. Number 10. Miss Macias has 9 apples in her fruit bowl. She used 6 of the apples to bake a pie. What percent of her apples did she use for the pie? So she used 6 out of 9. We have to change 6 out of 9 to a decimal. So we divide. 6 goes in the house, 9 goes outside. 9 doesn't go into 6, so we put a decimal and a 0. How many times can 9 go into 60? Remember, you can skip count on the side.
times.
54, that would be 6. With 6 left over. Oh, look, it's repeating already. So the only one that looks like 66 is H.